Hello students, this is Professor Chalai, and in this video we're going to look at percent composition, specifically the mass percent composition. By the end of this video, you should be able to compute the percent composition of a compound. As always, you can follow along with what I'm doing using our chapter worksheets. So what is mass percent composition? Simply put, mass percent composition is just what percent of an element of a compound, is composed of each of its specific element. So a formal definition for mass percent composition would be the percentage by mass of each element of a compound. For example, let's say you're looking at water as an example that we use often. We know that hydrogen has an atomic mass of about 1.01 atomic mass units. Oxygen has an atomic mass of about 16.00 atomic mass units. However, there are two hydrogens, right? So if we were to look at the mass percent composition of hydrogen specifically, it would be 2 times 1.01 atomic mass units for hydrogen divided by the total mass of the compound. So hydrogen plus oxygen. So up here we got the mass of one element, whichever element you're using, and on the bottom you have the total mass, and times 100%, right? That is effectively the definition of mass percent composition. It's the mass of one element divided by the total mass times 100%. And whichever element the mass you're taking of is the one that you're interested in. In this case, we're looking at the mass of hydrogen. So let's look at some examples from your worksheet. You can try these by yourselves based off of the definition. So let's write that. So it's equal to the mass of one element over total mass times 100%. So try number 12 on your own. See if you could figure it out. Pause the video, and when you unpause, we'll go over it together. Okay, so number 12 asks us to calculate the mass percent composition of chlorine in C2Cl4F2. So we have C2Cl4F2. So in each of these cases, we have to figure out what are their atomic masses before we can calculate the total mass, right? So carbon has a mass of 12.01 atomic mass units. Chlorine has an atomic mass of 35.45 atomic mass units. And fluorine has an atomic mass of 19.00 atomic mass units. You can find these values in any periodic table. So if we're looking at the mass composition of chlorine, then what we have is the 4 times chlorine, right, on top, divided by, on the bottom is the total mass. So we'll have 2 times 12.01 for the carbon, 4 times 35.45 for the chlorine, plus 2 times 19.00 for the fluorine, and times 100%. And so for the percent here, we come up with something like 69.57% of chlorine. So if you were to separate this compound into various elements and weigh each of the elements, 69.57% of all the mass would be of chlorine. Okay, number 13, slightly different. Here it's giving us the total mass, and it wants us to figure out what's the mass of the oxygen within this sample of aluminum sulfate. See if you can figure this one out by yourself as well. Pause the video and see if you can work it out. Otherwise, we'll go over it together. Okay, so aluminum sulfate, we have Al2SO4 Let's see if we can work this out. So aluminum has an atomic mass of 26.98 atomic mass units, but there are 2 of them, so it'll be 2 times that. Chlorine has an atomic mass of 26.98 atomic mass units, but there are 2 of them, so it'll be 2 times that. Oxygen has an atomic mass of 26.98 atomic mass units, but there are 2 of them, so it'll be 2 times that. Sulfur has an atomic mass of 32.07, but there are three of them, right? There's a three out here. And oxygen, oxygen has an atomic mass of 16.00 atomic mass units, but there are 4 times 3, there are 12 oxygens, right? We need to make sure we count all of the oxygen atoms. So if we're looking at the percent mass of oxygen, so percent mass of oxygen, we have 12 times 16 on top, and on the bottom we'll have 2 times 26.98 plus 3 times 32.07 plus the 12 times 16.00. All of this multiplied by 100%, and it comes out to about 56.11%. But that's a percent mass of composition of oxygen. So 56.11% of the total mass would be the mass of oxygen. And they give us the total mass. So the mass of oxygen should be 56.11% of the total mass, which is 7.2 grams. Now, percent just means divided by 100, so there's 56.11 divided by 100 times 7.2. You plug that into your calculator, and you should get 4.0 grams to 2 significant figures, right? 2 significant figures. And that's our answer for number 13. So here we first had to find the percent mass composition of oxygen, then use that on the total mass. So total mass to find the mass of oxygen that we were looking for. Okay, number 14 takes this one step further. Here, we're asked to find the total mass given the mass of iron. See if you can work this one out by yourself. Pause the video, and when you unpause, we'll go over it together. Okay, so there are a few steps to this one. First, we have to figure out what is iron 3 oxide. Well, iron 3 means that it has a charge of 3+. Oxides, we know, has the ion O2-. So to figure out the formula for iron 3 oxide, if we multiply the oxygen by 3 and the iron by 2, the charges should balance out, right? So we'd have a formula of Fe2O3. That's iron 3 oxide. In case you want to make sure the charges balance out, we have 2 times 3+ charge plus 3 times a 2- charge. And so this will give us a 6 positive charge, a 6 minus negative charge that cancels out. Okay, so now that we have our formula, this was our first step. Now we can figure out what are next we need to figure out what the percent mass of iron is in this compound. Okay, the atomic mass of iron is 55.85, and there are 2 of them in this compound. And the atomic mass of oxygen is 16.00, and there are 3 of them in this compound. So 2 times 55.85 for iron divided by the total, 2 times 55.85 plus 3 times 16.00 times 100% gives us a percent composition for iron of 69.94%. 69.94% iron. Okay, so we know in this compound 69.94% of the total mass should be iron, and it tells us what that mass is, 58.7. So let's look at this. 69.94% of whatever the total mass is, let's call it X, should be what the mass of iron is, which is 58.7 grams. So what is this total mass X, which is what they're asking us to find? Well, all we need to do is divide both sides by 69.94%. 69.94%. And we know that percent just means divide by 100, so x is equal to 58.7 grams divided by 0.6994, right? That's 69.94%. Punch this into a calculator and you get a mass that is about 83.9 grams to 3 significant figures. Right? Grams over here, grams over here. Just to check that this makes sense, the total mass should be greater than just the mass of one of the components. So this is the mass of just the iron. So there we have it. So in summary, the mass percent composition is just the mass of whichever element you're interested in over the total mass times 100. And there are various ways to use this in calculations. Here we just calculate the percent mass of chlorine. Here we use the percent mass of oxygen to figure out what the mass of oxygen was in this compound if we were to separate all of the elements. And here we did the opposite. We used the percent composition of iron to figure out what the total mass should be if we have the mass of iron in the compound. All right, in the next video, we're going to look at empirical formulas. Until then, I will see you later. Bye.